Topic 1: Introduction to the mole concept. The mole concept is a fundamental concept in chemistry that helps us understand the quantitative aspects of chemical reactions. It provides a way to count and measure atoms, molecules, and compounds. The mole, symbolized as mole, is a unit used to express the amount of a substance. Topic 2: Avogadro's number. Central to the mole concept is Avogadro's number, named after the Italian scientist Amedeo Avogadro. Avogadro's number is approximately 6.022 times 10 to the power of 23 and represents the number of particles, atoms, molecules, ions, etc. present in 1 mole of a substance. Topic 3: Molar mass. The molar mass is the mass of 1 mole of a substance and is expressed in grams per mole, g per mole. It is determined by adding up the atomic masses of all the atoms in a molecule or formula unit. The molar mass allows us to relate mass to the number of moles of a substance. Topic 4: Converting between moles and mass. To convert between moles and mass, we use the equation moles equals mass, molar mass. This equation allows us to calculate the number of moles of a substance if we know its mass, or vice versa. Topic 5: Convert into moles and number of particles. Since 1 mole of any substance contains Avogadro's number of particles, we can convert between moles and the number of particles using the equation. Moles and particles are related through Avogadro's number. 1 mole contains approximately 6.022 times 10 to the power of 23 particles. The conversion equation is moles equals particles, Avogadro's number. Moles and particles are related through Avogadro's number. 1 mole contains approximately 6.022 times 10 to the power of 23 particles. The conversion equation is moles equals particles, Avogadro's number. Moles equals number of particles, Avogadro's number. This equation is useful for converting between moles and the number of atoms, molecules, ions, or any other type of particles. Topic 6: Stoichiometry and the mole concept. Stoichiometry is the study of the quantitative relationships between reactants and products in a chemical reaction. The mole concept is crucial for stoichiometric calculations as it allows us to determine the ratios of substances involved in a reaction. By using balanced chemical equations, we can establish mole ratios between reactants and products. These mole ratios help us determine the amount of one substance required to react completely with another, or the amount of product that can be obtained from a given amount of reactant. Topic 7: Percent composition and empirical formulas. The mole concept is also employed to determine the percent composition of elements in a compound. The percent composition indicates the proportion of each element's mass in relation to the total mass of the compound. It can be calculated by dividing the mass of each element by the molar mass of the compound and multiplying by 100. Additionally, the mole concept assists in determining empirical formulas. The empirical formula represents the simplest whole number ratio of atoms in a compound. By comparing the molar ratios of elements in a compound, we can deduce its empirical formula. Topic 8: Limiting reactants and excess reactants. The mole concept is essential for identifying limiting reactants and excess reactants in a chemical reaction. The limiting reactant is the substance that is completely consumed and determines the maximum amount of product that can be formed. The concept of moles allows us to compare the amounts of reactants and determine which one will be completely consumed. Excess reactants, on the other hand, are the reactants that are present in excess and remain after the limiting reactant is completely consumed. The mole concept allows us to determine the amount of excess reactant left over and calculate the theoretical yield of the reaction. Topic 9. Molarity and solution stoichiometry. Molarity is a unit of concentration expressed as the number of moles of solute per liter of